Hi there, my name is Emery Rounds, and this is my presentation for Info 281, Section 15. It's called When Optimism Isn't Enough, and basically it's about the shortfall of preparedness for an earthquake or lahar in the southern Puget Sound, and basically the crisis informatics that are associated with sort of trying to prepare people. Preparedness is basically the best option when you talk about natural disasters of this scale. In a way, there really isn't a lot that people can do once the disaster has occurred, especially since lahars in particular and tsunami waves, it's basically a get yourself out of danger or die scenario. So if people are aware, they can remove themselves from the threat areas. I began this presentation with a photo of Mount Rainier. This was taken southwest of Tacoma. It's just basically here to give you an idea of sort of the scale of this mountain. It's 14,411 feet tall, which makes it a little tiny bit shorter than Mount Whitney in California. But it's the 21st tallest freestanding mountain on the planet, which is to say that its base to peak height basically exceeds Everest, because when you talk about Everest, you're talking about a mountain that's on top of the shoulders of other mountains. Mount Rainier rises essentially from sea level. So it's a very, very impressive mountain, and it is essentially just a gigantic pile of ash and erupted material, which makes it very, very unstable. I'm going to start this presentation by talking about sort of the geologic background and then move into the crisis informatics. A little over 500 years ago, a large mudflow occurred on the flanks of Mount Rainier called the Electron mudflow, and it devastated the present-day sites of the towns of Ording, Sumner, and Puyallup, which are basically sort of northwest of the mountain. It caked these areas in upwards of 30 feet of mud. And the mudflow, like most lahars on the sides of Mount Rainier, was predicted to have flowed at in excess of 60 miles per hour, which is to say that it would have struck Ording less than 15 minutes after breaking loose on the side of the mountain. Now, what are lahars? Lahars are basically sort of a giant sloppy sluice of ash, mud, and melted snow. They can occur without preceding volcanic activity, which is something a lot of people don't know. This is to say that the mountain doesn't have to be erupting or releasing steam or anything along those lines for a mudflow, for a lahar to occur. It's essentially very tall volcanoes are essentially very unstable systems. They're composed of hydrothermically altered rock, and if you were to imagine a big pile of sand, essentially. So large portions of them can break loose. And the electron mudflow was basically an example of that happening. Scientists don't think anything caused it. It just sort of occurred. Larger lahars have happened at Mount Rainier as well. 57,000 years ago, or 5,700 years ago, excuse me, the Osceola mudflow knocked an estimated 2,000 feet and hundreds and hundreds of thousands of tons of material off the mountain's summit. This was such an expansive lahar that it spread over 50 miles from the summit of the volcano and fully filled in a 30-mile arm of Puget Sound that extended all the way from present-day Auburn and Kent up into southern Seattle. That's a lot of material. This is basically just a lahar map. I'll get back to this in a little bit, but I just wanted to give you an idea. You can see the black spot in the lower right-hand corner is the summit of the volcano, and then lahars generally follow river channels and then sort of spread out when they reach lowlands, and you can see once it gets to Enumclaw and Sumner and Ording and stuff, it starts to sort of spread outwards. And then up there with Kent and Auburn, you can see basically sort of the vestiges of the Osceola mudflow. Moving along, every 300 to 500 years, the region is struck by a 9.0 megathrust earthquake, similar to the Japan's 2011 Tohoku earthquake, which generated the famous tsunami. These earthquakes are not like what you experience in California. They generally last over 5 minutes, and this is because the fault is breaking along the entire 600-mile system. They cause very large earthquake waves, PNS waves, and because of their length, you're not shaking for 30 seconds, you're shaking for, 400 seconds or 300 seconds. Scientists don't exactly know what's going to happen when one of these occurs in a place like Seattle or Portland, Oregon. You could be talking about, buildings falling over, skyscrapers falling over, and things like that. They also generate large coastal tsunamis. This is just a reference point for what we're looking at here. You can see the Juan de Fuca plate is sort of the source of this. You can see the plate is sort of subducting over underneath the North American plate. Seattle and Vancouver on the right-hand side there, and the earthquakes are generated when the plate slips, basically, and as well as the melting of the plate once it gets underneath the crust is what creates the volcanoes. And just to quickly touch on this, until the late 1970s, geologists didn't think that large earthquakes occurred in Seattle. But the tip-off was when they began to discover both submerged trees along the coast, where the land had basically fallen like a dozen feet, plunged downwards in the midst of the earthquake, and been flooded by a tsunami. And then Japan had a recording, a very detailed recording of a tsunami occurring without a preceding earthquake on January 27, 1700, and they were able to realize that what generated that tsunami wave was actually an earthquake in North America, in the Puget Sound region. Also, the lahar threat was only vaguely appreciated until the 1980 eruption of Mount St. Helens, which generated very minor lahars that did not really threaten very many people, but it sort of woke the area up. And as I said earlier, these events are unavoidable. Preparation and education is the only option. This is just a photograph of a model simulating the 1700 Cascadia tsunami, the orphan tsunami. So, getting onto the crisis informatics portion, education and awareness are basically the best way to prepare people to spread information about the pending disaster. In 2001, the region was sort of woken up a little bit with the 6.8 magnitude Nisqually earthquake. It only killed one person, and it caused a lot of damage, but it sort of raised public awareness, although I quote Dean Patton in 2011 and in a newspaper article that said, ultimately damage may reach into the billions, that only one person died and few buildings had significant structural damage, which is kind of indicative of the local reaction of a pat on the back, and we did so well. One option in educating the public is hazard maps. These display danger zones, give people an idea of where to flee in the event of a lahar tsunami. Have some examples of hazard maps right here. You can see on the right there's an earthquake hazard map, just giving an idea of the magnitude of the earthquake in a given area. And on the left is sort of a directional to tell people where to flee in the event of a tsunami along the coastline. As far as programming is another great way to sort of reach out to people, particularly children. Recently in October, in the midpoint of the month, I believe the 15th, Washington hosted the Great Washington Shakeout, which is part of the larger Great American Shakeout. This was basically sort of a dry run of what would happen in an earthquake, and you could see children there sort of under their desks. Local groups will also put on talks and things like that about earthquakes, and another great way to sort of reach out to people is that Seattle Emergency Management has also hosted like retrofitting classes and things along those lines to sort of get adults in, and while you're simultaneously teaching somebody how to retrofit their house, you can teach them how to, there's a major earthquake threat, a major lahar threat. Another great method to get people aware is sensationalism. I in my paper I talked about a number of different, basically outrageous or semi-outrageous claims or books or things that have been written or created. I mean, obviously that wave is computer generated and a joke. Tsunami waves are never that large. Sandy Doughton's Full Rip 9.0 was written not by a scientist but a newspaper reporter, which is, she's not really qualified to talk about about earthquakes or anything along those lines, but she very much sensationalizes her writing, but it grabs the attention of people, gets them aware. And prepping, of course, everybody knows that prepping is a major sort of pastime in the U.S. lately, getting ready for whatever, the great disaster. So a lot of articles have been focused on prepping for the earthquake Lahar. Government response, as far as I looked in my paper, the Pierce County Emergency Management Plan. Basically, they had 5 major points. They were going to adopt a terror-like alert color threat system, which seems kind of silly. They were going to encourage people to purchase a no all-weather radio, which is a nice thought, but encouraging people is not going to actually get them to do it. They were going to post updates on a website after the event of Lahar, which is silly because who is going to receive those updates? They were going to activate emergency radio and air sirens, which is a great plan. That's basically sort of the first and last line of defense. And their final plan was to open a joint information center to coordinate additional responses, which is a great idea unless, half the people who are involved in coordinating your joint information center are dead. The article was noteworthy in that it lacked any kind of an evacuation plan. So in the event that the Lahar occurred in the middle of the night or during rush hour, people were just kind of screwed. So, I don't think that a lot of local officials really have a grasp of the magnitude of the situation. And so far, tests of sirens and things like that have not really sufficiently modeled what an evacuation of this scale having to occur in a 15 to 60 minute time window is going to look like. And that's an example of the color aviation, aviation color codes, but this is the scale that the Pierce County Emergency Management people were going to borrow. And just briefly, I want to touch on Nathan Wood and Christopher Solo had published Variations in Population Exposure and Sensitivity to Lahar Hazards from Mount Rainier. And that was a study on how people react given sort of their location, their backgrounds, like if they were working, how do they react? If they were at home, how do they react? What do they do? What is their time frame? That's sort of an example of how scientists have approached this method of modeling how people are going to get out, and that's how government entities like the Pierce County Emergency Management build their plans in order to evacuate people and to prepare them, is to look at studies that model how people are going to react. Monitors have also been placed on Mount Rainier, but they've previously failed to sound sirens during tests, and in 2007 there was an incident where an employee accidentally triggered the alarm. Even worse, only one radio station actually carried the alarm. The rest suspected that it was a mistake, which is all well and good, except that if a repeat of the electron mud flow occurred, then that would have been too late. I also really briefly touched on library response. I interviewed the directors of the Orting and Fife libraries. They stated that they host geologic-themed programming and they possess evacuation plans for their patrons and their staff members. In the aftermath of the 2001 earthquake, libraries communicated immediately after the shaking stopped. They checked up on each other. They implemented plans as to how they were going to alter their infrastructure, bolt down shelving units and things along those lines. It was an example of communication in the aftermath of a disaster. It's imperative, obviously, that librarians are aware of their surroundings so that they can properly direct patrons to new information, just to sort of emphasize sort of the preparedness element of this paper. And this is the last slide. What can be done? Well, more public involvement. There was a pilot program in Seattle that basically installed seismometers in people's houses, which is a great sort of boots on the ground way to get people connected to geology and also sort of invest the community. And like if somebody has a seismometer in their house, neighbors might want to know what happened after a small earthquake, and it might get them thinking. And of course, better utilization of modern technology. It's all well and good to tell people that they want to, buy them, want them to buy NOAA weather radios, but a better plan would be to implement Amber Alert style notices that flash onto people's cell phone in the immediate aftermath of a Lahar being detected or an earthquake being detected, and just get cover. Systems like this have been adopted in places like Japan, but in the United States, it seems like we have to suffer a disaster in order to properly plan for it. And that is my presentation. Thank you very much.